Greetings to you, dear ladies and gentlemen. I'm pleased to submit for your attention this all my work. And it's titled Automatic Assessment and Analysis of Image Visual Quality Metrics. The scope of this work covers the goal of designing means for evaluation of image quality metrics. And here I mean full reference image quality metrics. First of all, I want to define four main principal goals of this work. They are investigating the temporary image database 2013. As you know, this is the new version of the database that our colleagues have created. We wanted to elaborate techniques for testing new metrics performance on the basis of this TID 2013. As well, there was a purpose of gathering facts all about existing solutions, so we could check out if we could do better. And the last step would be designing and picking up all the technologies needed for implementing all these means for assessment of full reference image quality metrics. Here's the big picture, and it's kind of a retrospective. I want to remind what I did before with my colleagues. It was a human visual system study, and the last time we modeled this whole human visual system according to three studies of curves, motion, and Barton. All these models were put into the discrete cosine transform coefficients table, and then we used these all coefficients to power their newly created PSNR HVSM metric. And then a special one was carried out on the basis of the TID 2008. And look at these achievements we gained. This is the Spearman rate order correlation coefficient, and it have been raised by 5% comparing to original JPEG tables that were put originally to the PSNR metrics. And Barton's model beats the default coefficients in 7 out of 12 subsets of the TID 2008. That's great. And this is our current research. And this time we move closer to metrics evaluation themselves. We want to test the productivity of newly created metrics in an easy and unattended way. So we can move out their human being factor and all this routine work, so you know it's much easier to press only one button and the job is done. This is by all means a great research, and I think such a great database like TID 2013 deserves a tool like this, because it's starting to get approval in their Society of Scientists all around the world. Of course, you know, I want to underline that that image quality evaluation is no doubt is of a big interest all around the world, and it's a great possibility for us to speed up the testing of newly created metrics. So other scientists turn their attention to our research, and this is by itself a great contribution for further development of the TID database itself. We tried to investigate and find out some other existing solutions that might be similar to ours, and we carried out the research and tried to find it, and guess what? There are none. So we are the first ones. That's great, isn't it? This is the workflow chart. First of all, I'll describe the work of our invention. First of all, we just take plain ASCII files, plain text files containing MOS and metric data. Then we put all this stuff into MATLAB scripts. MATLAB scripts runs different procedures and generates all kinds of charts, histograms, bar plots, tables, and other data that we save in temporary location XML and EMF files on a hard drive. Then it's the time when the C# engine, auxiliary engine, kicks off and it starts picking up all the results from the MATLAB part, and it generates a human-readable output, so the scientists can read it and examine the productivity of their metrics. This is the content list of the output report protocol. It's RTF formatted, which means rich text file formatted. And we have 10 customizable sections. And you can see there are a lot of examples of these ones. I'll scroll a little bit further, up to 10 slides or something like that. And we'll see all the examples and the samples of the data we can gather. These are all the Spearman and Kendall rank order correlation coefficients for the examined, in this case, FSIMC metric versus MOS and other reference metrics. Among them are the PSNR, MSSSIM, SSIM, and PSNR HMA. This is the histogram of the MOS values. This is some data showing correlation between the so-called perceptual subjective quality subsets of the TID 2013. This is the same for the Spearman rank order correlation coefficients. This is a very interesting chart. We can see the disparity weight among all the 24 distortion types of the TID 2013, and we can see that the 18th one leads and it takes the most error on its part. And it's, by the way, if I'm not mistaken, it's the color desaturation. It's the new one that we have been added to the database after the 2008. This is the sample scatter plot. This is another scatter plot, impulse noise versus additive noise. These all results are combined together so we can see difference. That's clear enough, I feel. And this is the combined chart where we can see all the examined metrics. This is our target metric, and these are all reference metrics. And this is all rates for Kendall's correlation coefficients for the entire set of Etalin images. And this is another section called abnormally scored image. As you can see, this is the example of desaturated image. As I have already mentioned, this is the 18th distortion type. And you can see that people put a low mark of almost 3 points. It's decently low. And on the contrary, FSIMC says it's great, it's almost 1, it's almost 100%, but we can have no color information in this image. And this is when this metric, I mean the FSIMC, is not correct. And this is the total abnormal scores for all the 6 subsets, excluding the full subset of the TID 2013. And this is the most important and innocent part of this event. These are the main characteristics of the tool itself and the output file. We have 89 images in total that are abnormally scored. We have 38 all kinds of charts. We have 13 tables. 2 of them are statically linked. And these are the results of the profiling. We've been working on making this as fast as possible, and it takes almost 50 seconds for the entire process from the beginning of the flow that I had shown you before. From the loading of the data to the generating report, it takes almost 50 seconds. And C# path works around 5 seconds, and it's pretty fast, I think. The entire space allocation on the disk is 25 megabytes. Total pages count is 82, and there are 4 different reference metrics so far. This is some economic calculation budget, Fiddle 6, and this is safety first, of course. And I feel like it's time to make a conclusion. It's great that I had an opportunity to take part in this work, to make a tool that has no samples in the world. And of course, it's great that I had an opportunity to combine all the MATLAB and C# code all together, and it's configurable via XML. It's improvement ready, so we can polish this all development to further move on. It has easily distributed sources, but especially some of my teammates don't like the operation times. They think this is a drawback, but some say it's not that slow. I mean, it takes around a couple hours to make a manual computation of all this metric productions, and this makes it in about a minute. I feel like it's not a big deal. Of course, there's much yet to do, and the main thing, I think, is the review that will be get in the end when we'll show this all to the scientist society. Thank you. I appreciate your attention. That's it.